Here we go. Hey guys, I'm recording, so, alright, so we're going to do it algebraically, and then we're going to do it graphically. Okay, so what are the roots? What do I mean by roots? X-intercepts. So those are the zeros of the functions, the x-intercepts, or the roots. So when you're solving algebraically, you need to identify the restriction. And the reason why is when you graph it, it's obvious where we can't be. But when you're doing it with autograph, that restriction is going to tell you some stuff. So when we do the restriction, what do we know? We know that the radicand, do you guys remember what the radicand is? No. Everything under the root sign has to be what? Positive. Has to be positive. Has to be, oh, you can't even see that. Has to be positive. So really what that means is the radicand, can it be equal to 0? Yes, because we can take the square root of 0. So let's do our restriction first. So what's my radicand? X plus 5. Now you're going to do an inequality that says this. So x plus 5 has to be greater than or equal to 0. You're just one step ahead of us, right? So we're going to start there because what this means is this has to be greater than 0. So those are all positive numbers, right? And we said we put the equal sign in there because it can equal 0 as well. So you're going to solve it just like you would an equation. So x has to be greater than or equal to -5. So what does that mean? Right, so if we were to put this on a number line, here's -5. Would it include the point -5? Yes. Right, so closed circle, and all my domain values would be in this direction. Does that make sense to everybody? So would -7 work? But would -2 work? Yes. Okay, so that's what you've just done with the restriction. Essentially, you've talked about where that graph has the starting point. Okay? And you guys know this, looking at this, where is the starting point? What are the transformations on this graph? What are the transformations? Tell them to me in words. Down 3 and left 5. Are there any stretches? No. Are there any reflections? No. So where does your start point happen on the graph? -5, -3, right? So all I'm asking you to do, so we're kind of doing part B too because we're kind of getting that visualization of it, of what's happening. Okay, now we got to solve. You ready? So we did our restriction, now we're going to solve. So x plus 5 minus 3 equals 0. Why is it equal to 0? Because what are we solving for? The roots. We're solving for the x-intercepts. So what's my y value? 0. So if this equation was given you like this, we would replace the y with 0, right? Like, these are all things that you guys know, but I've thrown a radical in and all your math skills just kind of you start questioning things. Okay, so what am I going to do first? We're going back to grade 11 on how to solve a radical equation. Move the 3. So step 1 is to isolate that radical to one side. X plus 5, 3, and then square both sides because we want to get rid of that root sign. And we got 9 on the side. Move the 5. You guys are too fast for me. Just 4, because we're not doing the action of square rooting. We squared. It's when you root. Okay. So what does this mean? And the x-intercept is going to be 4. If I was to put that out as a coordinate pair, it would be 4, 0, right? Okay. All right, we're doing pretty good. So you've just solved that algebraically, but you need this. Okay, so you need to do your restriction first. All right, now we're going to graph it. So do you want to do it transformations? Probably, that's easiest. Okay, what's our original table?
0, 0, 1, 1, 4, 2, 9, 3.
So 0, 0, 1, 1, 4, 2, 9, 3. Okay, what is our transformed graph? So y equals root x plus 5 minus 3. And you guys told me that that means I'm going 5 left, so I'm subtracting 5, and I'm subtracting 3 from the y's, right? So -5, -3. Yep, for sure. So this is going to be -4. That's going to be -1. And that one will be +4. And then I'm going to have 1 minus 3, so it's going to be -2. -2 minus 3 is going to be -1. And 3 minus 3 is 0.
So wait, do we just have to memorize that one table?
Yeah. Just kind of like the sinusoidal graph, like
You have to memorize the whole.
like you had to know the values for the sine graphs. You had to know the values for the basic cosine graph. Well, these were just perfect squares. The square root of 0 is 0. Square root of 1 is 1. We just picked nice numbers, like, so we didn't pick 2, so that you don't have to remember that the square root of 2 is 1 point something something. We just picked nice numbers. So it was a very purposeful X selection, and we knew that we couldn't have any negative y's, right? So we couldn't have -2, right? Because the square root of -2 we can't find. So, okay, let's graph it. Hey, good news though, you guys get your calculator for this whole quiz and test. Does that feel good? Okay, I'm trying to bail myself out of a bad situation. What? I don't think so. Yes, I do agree though, like with your calculator, there's unlimited possibilities. Without a calculator, you know it's going to be reasonable, right? All right, so what happens between those first 2 points? Bubble. Okay, I'm back to drawing pretty good graphs. Yeah, like that was, feel good.
Do we have to do the negative roots always, or just when I ask?
Just when I ask. Okay. Yep, you can answer C. You already answered C. What's the connection between finding a root and finding an x-intercept? They're the exact same thing, right?
Do we have to put points on the graph?
Yes, we should. How many points?
2.
Just 2. Just in case you want full and complete notes, that's what they look like. All right, this is exciting. This is a little bit of grade 11 coming back at you. Yep. Hi. Sure, I'm just recording a lesson, so. Okay. I can't pause this, so I feel kind of bad, but you guys are the most important. You guys are the most important. Okay. So we're gonna do it algebraically, and algebraically we learned in grade 11. If you remember that far back. It's a good time, the best of times. Anybody want to tell me what the restriction is?
X can be greater than or equal to negative 5?
Exactly. It's the same one, eh?
Yeah.
So x plus 5 has to be greater than or equal to 0 for my restriction. So, I didn't leave myself much room.
What about the, never mind.
Okay, so that's my restriction again. So it's just about the radicand. So you just want to get in the habit of doing that.
Miss Einhard can help us identify the answer on other routes. I was finding the restriction a lot.
It will tell you if your answer is an extraneous root.
Like it's part of the graph, but like it's beyond.
So sometimes, so in this case, we're going to square something, right? And you know how negative 2 squared is 4 and positive 2 squared is 4? So sometimes because we're doing the act of applying a square, we always take that positive principal root kind of thing. So sometimes our answers will come out and they'll be wrong. They're an extraneous root. Algebraically they work, but when applied to the graph with the restriction, they can't. Okay? So it's kind of like, you know, when we solved for quadratic equations and it was like, how many CDs can you have? And you get a negative number and you just reject it.
Okay.
Okay? Okay, I'm recording a lesson.
I can wait. How long is it?
At
Oh, we
least
just started.
we just started, yeah.
Okay.
Okay,
Yeah.
all right. Okay, obviously I'm very popular today. Okay, so are we good with this? So that's what the restrictions are for. So we're going to go back to grade 11. Step 1 of solving an algebraic radical equation is to isolate the radical. Is the radical already isolated? Yes, it's by itself on one side. So what's the next step? Square both sides. Do you remember? Okay, so the square is going to cancel out the square root. So I'm left with x plus 5 on this side. What do I have to do here? Right, you have to expand it. Don't give me x squared plus 9 or I'm leaving. Okay, so this has to be x plus 3 times x plus 3. Right? You have to expand it because you're going to have that middle trinomial, like the term that makes it a trinomial. Yeah, so again, we're solving for x-intercepts, so we know we've got a quadratic here, so we either have to do one of two things. What are we going to do? We're going to factor, or we're going to use quadratic formula. Either one will work. I think this one I can factor, but I got to get it equal to 0. I can't just factor this one side. I got to bring this stuff over to the other side. So I'm going to have 0 equals x squared plus 5x plus 4. And I didn't show my math. I know, feeling pretty crazy. Okay, so I think in these situations, factoring would be easier than using your quadratic formula because this one factors really nicely. You're looking for the two numbers that multiply to 4 but add to 5. 4 and 1. Okay, so if I'm going to solve these, you set each factor equal to 0. So how do you feel about that? That's pretty straightforward. But now we got to go and we have to check our answers. We have to check our answers. You sure?
Or no, just like in the actual equation.
We got to go back and check them in the actual equation.
Like, can't we just see like they fit their restrictions here?
No. You got to go back.
So what is the point of
This is grade 11 Italian. Wow.
This is so grade 11. Is that true? Yes. So that's a good answer.
Wait, how do you know that's, oh, this is wrong.
Is that a good answer?
Yes. Oh,
No, you take the positive principal root when you're square rooting in a check. Do you guys know what I mean by positive principal root? What's the square root of 4? 2. You've just found the positive principal root because it's positive and it's the most important. So this is
yeah.
and so you have to indicate that that second answer is rejected.
So you have to check every time it's accurate.
Yes. You have to check every time when you're solving a radical equation. Just for funsies. It's where your graph's going to start. It's going to, you know what, you guys can stop mocking me, okay? All of you.
You're a trendsetter.
I'm sure that's what I am. Funsies.
I love it.
All right. Okay, so here's the thing. This becomes really hard to graph. This becomes really hard to graph. So for the last one, we just had the 3 on the same side. But if we moved everything to the left-hand side,
What is that?
exactly, what is that? We can't graph that. That's not going to graph nicely because you're dealing with a root, then you're dealing with a regular x. There's no transformation that includes a variable in it, right? So we have to have another strategy to graph these weird situations. Please note that this is not on the quiz tomorrow. Okay? Just want to point that out. It is on the test.
I actually like this more than the previous one.
Okay, so you're going to break this into 2 equations.
Well, when you have a choice between doing geography
Yeah.
Miss Callie, do we get a choice between doing geography or algebraically? Later
Do
on.
the second one.
No, you have to do both of them.
No, the second one.
Okay, second one first. Okay, for sure. So when we graph 2 lines, we're going to be looking for the point of intersection. What is that?
Oh, when they intersect each other. When they hit each other. When they intersect.
Okay, so the solution is going to be that point of intersection, and that's just where those 2 graphs cross each other. Okay, so let's graph our nice linear equation first. No, I get in trouble if I do it already. I know, I'm learning. I'm learning. Just taking a moment to label my axes. All right. I just labeled my axes. I haven't done anything else. Okay. I want to use slope-intercept instead of a table because I think that will be faster for us. Super easy. What's the slope on this one? 1 over 1. So what does that mean? We're going 1 up and 1 to the right. But where does my graph start? At my y-intercept of 3. Guys, this is what my grade 10s are struggling with. They're having a hard time. Okay, so there's my y-intercept of 3, and my slope is 1 over 1. So it's up 1, over 1, up 1. Oh. Yeah, we probably should. So we can go this way, up 1 to the right 1. How do I get numbers that way? Down and left. So it would be -1 divided by -1, which is still +1.
But if you don't reach -5 before it goes negative,
That's okay.
you keep going. I don't think that exists, no?
You can do whatever you want. Is this going to go on forever? Yeah.
Restrictions?
There's no restrictions on a linear, right?
Oh.
Right? We're doing that linear graph. Okay. We ready? Because we got to do the other one. Okay. This is where the restriction comes into play. Where does this graph start? At -5. Right? Because what's the transformation on this one? 5 left. So where's my original point with 0, 0? There's no up, down here. There's no stretches. So that 0, 0 is going to go -5, 0. Okay, -5 and 0. My next one, maybe it'd be good if we did a table of values for this one. So 0, 0, 1, 1, 4, 2, 9, 3. And so y equals x plus 5. Anything going to happen to my y's? And this goes to -5. This is going to go to -4. This one's going to go to -1. And this one will go to +4? Sorry, I didn't show you that. All right, so I got that first one. Okay, all right. Slow down. I got it.
I wish you could like copy and paste.
Yep.
The example after this one
The example after this one
doesn't
doesn't have any lines?
for the graphic. And if it's fine, you couldn't do it.
Well, no, it's gonna be on quiz.
It's actually not gonna be on the first camera, that's actually hard at this point, but whatever.
Oh my goodness. Okay. Okay. Am I good to continue on? Can I graph these points? So -4 and 1. And -1 and 2. Oh, look at that. Oh, look at that. And 4 and 3. You guys are like brutally mocking me today. Between the first 2 points, what do I need? Bubble.
What if the point isn't easy to see?
It's going to be if I ask you to solve it graphically. Okay? All right. So where's my point of intersection? So my point of intersection. Welcome to my world. So what's the answer for this? Because all I want is domain.
What is that? Why is it only n?
Because that's the only one we need, and because we split them, the y values would be different. Can I just slide up for a sec? What was my answer up here? X equals -1, not that -4, right?
Oh, would this change if it was like a rad kind of like range? There'd be like 2 x values.
That's what's going to happen next.
I just miss that?
Okay, am I good to flip?
Are we gonna have a quiz between graphing and algebraically? No, we're not.
What do you mean? Are we gonna have a quiz?
Are we gonna have the choice between
No,
graphing and
no,
algebraically?
you crazy kid, no.
I'm not. Oh my God.
I would much rather solve every time algebraically.
How about on the actual exam?
I'm gonna make sure you have to solve graphically.
Oh.
No, you know what, chances are, the question I think that's gonna be on the exam, I can't say that for sure, exam's so far away. In the past, I've just given a radical equation with some transformations on it, and you had to graph it. But I didn't ask you to solve it. I just asked you to graph a radical equation, but that was in the past. This is a new year. Who knows what the exam will look like? Okay. All right. All right, ladies and gentlemen. We ready? Okay, back to grade 11. Back to grade 11. You know what? Let's just talk about it for a second. Let's just talk about it for a second. If we were to graph this, let's talk, so we would have two equations. First equation would be the radical one, and the second one would be the linear. Remember how nice and easy that linear was? So let's talk about what that radical graph would look like. This is, okay. So if I were to process this in my head, the first thing I would do, I'm just going to pop over here for a second. My scrap paper is getting pretty full. I'm going to look at what this graph looks like. So let's talk about that graph. Where is the vertex? 0 and -5. Which way does my graph open? Okay, so if I were to do the root graph of this, what would be important? Oh, sorry. If I were to do the root graph of this, what would be important to help me do this? X-intercepts. That's just algebra, okay? That's just algebra. So, we could do that. I'm not even going to use the quadratic formula. Nope. Okay, so where are my roots? One's at positive root 5 over 3, and one's at negative root 5 over 3. Okay? Yeah. Because we know that there's two x-intercepts there, right? Like we know that, so the two are important this time. So what is that radical graph going to look like? It's going to look like that, right? Because we know that this can't exist. You guys all agree with me? And we just found those. So that would be nice if I just graph that one. So we've done part of this. We've done part of this already. So what would be the next strategy? No, now I need to put that other piece on there. So now we're going to graph. Can you graph that? Yes. So I'm going to have something that does, oh, this isn't going to work. I know, it's going to look like that, because you're going to actually have two. I wouldn't ask you to do this one. I'm going to show you it on Desmos. Just really quick. Oh. I wouldn't ask you guys to do this one on a test or on a quiz, just because technology, or an exam, because it would be really hard to do technology-wise. Ooh, I forgot my equal sign. Okay, that's my first one. No. What was my equation? 3x squared, thanks. I was still stuck on the other one. It had a 5 in it. Call that a win. Okay, so I think the most important part of this, and unfortunately these things don't show up on the video because it's looking at this stuff, not at what's on my computer screen. The most important thing that you guys get from this is, where is my solution? Or where are my solutions? It's the points of intersection, right? So when you graph those two parts, you're going to have two. You're going to have one right here at 5.8, and you're going to have one here at negative 1.8, okay? Those x-intercepts are where we thought they would be. 1.291, and this one should be the negative version of it. So that's the graph technology-wise. I would never ask you to do this one just graphically, but I am going to ask you to do it algebraically. Okay, can you do this algebraically? Yes, you can. What's step one? Okay, what's the restriction?
Oh, I don't know. Yeah,
You can do it.
but there's a square.
That's okay. You did it already.
X has to be greater than or equal to root 5/3.
No.
Yeah. And?
And
What do we do?
Okay, I'm going to go back to the pretty picture. So you gave me this restriction. You gave me that restriction.
square rooting goes to, oh my God. do I
You have to use both,
Okay.
yeah. Okay, can I tell you guys that you don't have to do your restriction? Would that help you?
Yeah.
Okay, don't do your restriction.
But I want to know how to do that though. Like I want to know.
I did it right here. So that's how I solved it. You could use the quadratic formula, but what does this need to change to? We need to say that 3x squared minus 5 has to be greater than or equal to 0, right? Because the radicand has to be positive. So we've got 3x squared is greater than or equal to 5. Divide by 3, divide by 3. So here's the thing. We're dividing by a positive, so does my sign flip? No, it does not. Okay, so now we're going to square root it. And with the action of square rooting, what happens? Plus or minus, thanks, Tirth. Right? So, but here's the problem. We're going to deal with this one first. So x has to be greater than or equal to positive 5/3, which we all agree with. We know that there's a negative 1. And if we go back to the pretty picture, what are these values? Those are negative. So x has to be less than negative root 5/3. So there's one.
I agree with the assertion that we shouldn't do
Those ones are hard to do on a parabola when you don't have the picture. Super hard to do. I think they're hard to do without the picture. Okay, Back to grade 11. We're done. We're done there. We're done. Those are the restrictions. There's nothing left to do. Okay, algebraically. Step 1, isolate your radical. This is grade 11 again. Is it isolated? So step 2. I hope so. Square both sides. Thanks, Basil. There's a lot of giggling going on. I don't really know what's happening.
We're gonna have to do the quadratic equation.
Yes.
That's why it's like
What twigged you to doing the quadratic equation? Oh, but did you look, but if you related it to the graph, where were my answers? They were at like 1.8 and 8.5 and stuff. So again, I have x squareds on both sides. I need to get it equal to 0. So I'm going to bring all this stuff to that side. Do you guys have a quadratic solver that you use?
I had one. Didn't need one.
something people should be bullied for.
We shouldn't be bullied for? I was asking if you downloaded the app that will do your quadratic formula. Like, yeah, there's some nice free ones. Photomath will show you how to do it, but I have one that I can just put the A, B, and C values in, and it tells me what's under the root sign, it tells me the factors. It doesn't show me the math, but it's really... So this is the one that I use. Oh, that's really... Oh, sorry, I'm zooming. It's just called Quadratics. So this is the one, it's green. This is the one I use.
You have an Android or an
iPhone.
Is it on?
I don't know. And then I can just put in the A, B, and C values.
I get the quadratic faster.
Does it work? Does it show you all the steps? So it's good. You'd use it in a situation where you want to check your answers really quick. Obviously, you don't have your phone on your test and stuff, so you do know actually you need to know how to do the quadratic formula, but if you're just checking. So I can put in just the ABC values, and then what it will show me is my answers, but it will also show me the discriminant. It will show me what's under the root sign. And if it was factorable over integers, it will do that for me as well. It will show me the factors. Oh no, it's free. It's handy. It's good to check your... Yeah. Is it the same app? Oh. Are you on an Android or an iPhone? Weird.
It's called quadratic though.
Yeah, that's what mine's called, just quadratic.
Yeah, but on the app it's called quadratic.
Oh.
On the browser it's called quadratic.
Okay. I don't remember what it was. I downloaded it a long time ago. Okay, guys, you're going to solve it using the quadratic. Go. Do it. Nope. Do it old school.
Oh, okay.
Do it old school using your quadratic formula. Nope. You know what your answers are going to be. You do, because you saw the graph.
No, I didn't. Oh, no, I don't have it.
But they were decimals.
X equals negative b.
So it might help you if you're remembering things. Yes, it is. So that first one, if I have a -8 and it's a negative b, what does that first term become? Positive. Mm. Okay, now solve. Solve for x, put in your calculator. Yep. So,
Do we have to do that step? Right now?
nope.
Do we round it?
Yep, let's go to 1 decimal place.
Do we have square root? What?
What? Oh, 1 decimal place. 1 decimal
Wait,
place.
can we square root it before we add?
Yes. Yeah. So, like when you have a fraction, you want to do, like you treat the numerator like it's got implied brackets on it. Yeah. Is it 5.1? No, I think it's 5.8. All right, that was a lot of grade 11 stuff. Okay. Word problem. Guys, the word problems in these have actually been really reasonable.
So, are you kidding me?
We've taken our time. We've taken our
Let's
time.
go to a page of like a half of it and giant paragraph.
It's not that bad.
It's too much?
I can't keep track of that.
Okay. All right. All right, engineer. You're designing a roller coaster. You now work for Disney and you're designing their newest roller coaster. Okay? So, right away, hi guys. I know it's difficult. Right away, it's given you the radical formula. So you know you don't have to create it or anything like that. It's there. You just got to know what the pieces are. So V is the velocity after the dropping distance. Dropping distance is d. The initial velocity is how fast it's going when it starts. That makes sense to everybody, initial velocity. And then A is acceleration. Okay? This is physics. This is very physics with a lot less steps. So this should be like very nice. So up to here is all about the equation. That's all the stuff that just defines the variables and tell you what they are, tells you your units, stuff like that. After that, this part is your question. That's the question. Okay. The design specifies that the speed of the ride's cars must be 120 feet per second. You're working at Disney now, so now it's all Imperial, right? So look, they're paying the bills. You just designed for them. Must be 120 feet per second at the bottom of the vertical drop section. Okay, so what letter is that? Oh. Okay, so it's in feet per second, so I know right away that it's a velocity. It's either my initial velocity or it's my final velocity.
It doesn't, well, what does the right do? I don't even know. Okay. No, it's final velocity, yeah.
It is final velocity.
Because the next sentence says it.
Because it says V in feet per second of the ride's cars after the dropping distance. So, specifies that the speed of the ride's cars must be 120 feet at the bottom of the vertical drop section. So, after it's dropped, it has to be going that fast so that it can make its next turn and continue on. Okay, so we know that that is V. That's V. All right, if the initial velocity, it even says that. So we know that V is 120. We know that V initial is how much? 10. Okay. The acceleration due to gravity, but we're in feet. That's meters, right? So this one's 32.
How are you writing your units with Scallion? That's so hardcore.
Yeah.
Okay. And what are we trying to find?
The distance.
We're trying to find that dropping distance, right? So that you make a ride that we're going to go fast enough to get through it and not get stuck. Okay? So what do you do with all this? Plug it into the equation. So is this hard? No. It's just a lot of reading, but you just got to pull it apart. You guys are smart people. Okay. Did you substitute it in?
Can you add 100 to 64?
Nope.
So do you
Okay, so
square it?
so you cannot add that 100 and that 64D. One has a variable, one has a constant, or one is a constant. You can't combine those two. So step 1, isolate the radical. Step 2, square both sides. Uh, 120 squared. Beautiful. So now what am I doing? Bring the 100. Divide out the 64. And I didn't leave myself enough room to put P.
That's it?
That's it. That's all. That's all you needed to do here. It was just algebra. Like, that's the easy part of this. Okay.